Good morning, everyone. Today we'll see now the experiment on second experiment, that is frequency modulation using IC 8038 and then its demodulation using IC 565. Okay. So first thing is we'll do the frequency modulation. So to do this frequency modulation, we are using this IC 8038. This IC 8038 as such, if you see, this is a 14 pin IC. This is a 14 pin IC wherein this is used as a function generator. Using this we can generate three different signals. One is we can generate a square wave, and also we can generate a triangular wave, and third one is we can generate a sinusoidal wave. Okay, so this sinusoidal which can be generated using this IC 8038, this sinusoid is used as a carrier wave. Okay, this sinusoid is used as a carrier wave, so that will be taken in order to do the modulation. Okay, so we have to apply a message signal externally, and the carrier is already generated by this IC 8038. So first thing is, I'll show you the diagram, the circuit diagram of this along with IC 8038. This is the circuit of frequency modulation. So first thing is, through this capacitor, the message signal M of t should be applied, and that M of t can be of from 1 kilohertz to 5 kilohertz. Okay, and up to a peak to peak voltage of 4 volts. Okay, the message signal will be applied to pin number 8 through this capacitor, and at pin number 2 we can observe the modulated output, FM output will be observed at pin number 2 of this IC. So before doing this, before finding out this modulated signal, first what we'll do is, let us not give this message signal. Okay, let us not give this message signal. Without the message signal, let us see this, whether this all these connections should be done. So don't give the message signal. Only thing is, we'll observe whether we are getting these signals here. Okay, without the message signal. So what you can see here, without giving, do all the connection, and first don't give the message signal, just observe whether you are getting a square wave here, that is at pin number 9, and triangular wave at pin number 3, and sinusoidal wave at pin number 2. Okay, I'll show that now. So the thing is, we have done here rigging up of the circuit, and this is IC 8038, and the appropriate power supply is given. Okay, the power supply, the voltage is given around 12 volts plus VCC and minus VCC has been given to this IC, and with all this, the same circuit connection, with this same circuit connection, do all this. Don't give message signal. Okay, other part thing we have to do. So after that, now, so first thing is whether this IC is working or not, we have to check by making the connection and without giving the message. Okay, so first we'll see here, I am connecting now at this CRO probe. The CRO probe I have connected at pin number 2. Okay, at pin number 2. Okay, pin number 2. So what you can see in this is, you can see on the CRO, this is at pin number 2 is nothing but sinusoidal signal. Okay, and when you get this sinusoidal signal, please also measure the frequency of this sinusoidal signal. So actually this function generator can generate up to some 300 kilohertz of frequency. Here the design has been done to generate around 33 kilohertz of carrier signal. So this sinusoidal signal, this is of 33 kilohertz. So that can be observed at pin number 2. Okay, then again one more thing is, I'll just connect this one at pin number 3. So at pin, I've connected now at pin number 3. So at pin number 3, now you should get triangular waveform. Okay, see, this is a triangular waveform, and this triangular waveform frequency is also same thing as that carrier wave, that is of around 33 kilohertz. Okay, then one more thing is, this FM generator can also, it also generates square wave. That square wave will be observed at pin number 9. Okay, So this is pin number 9. Okay, we can see here this is pin number 9. So we connected now at pin number 9. Okay, so from pin number 9 you should observe now square wave. So this is of little bit high. Okay, this is the square wave generated. Again this square wave is also of 33 kilohertz. Okay, so first thing is we have to verify whether the IC is working. So what we have done is, after doing this connection without giving this message, just observe pin number 2, 3 and 9. Here we should get sinusoidal, here it is triangular, here it is square wave. Okay, once this is verified, and measure the frequency of this sinusoidal here, that should be around 33 kilohertz. That is what we have designed. Once that is verified, now we can apply this message signal here. Okay, apply this message signal. So we are applying the message signal. So I am connecting now message signal. You can see here, this is the message signal of around 4 kilohertz. Okay, I am giving here 4 kilohertz, and peak to peak message signal amplitude we can set around 4 volt peak to peak, and frequency we have set around 4 kilohertz. Okay, so this message signal from this signal generator, this message signal of 4 kilohertz, that will connect to pin number 8 through this capacitor. Okay, to the pin number 8 through this capacitor. So that I am applying here. Okay, I am applying here. Okay, so I have applied here the message signal. Once the message signal is applied, now we'll see the modulated output. Modulated output will come at pin number 2. Okay, so modulated output will come at pin number 2. So this is the modulated FM modulated output. Okay, this is what you can see. So that is the FM modulated output which can be observed from pin number 2. So the thing here is, what is FM modulated? You are giving a message signal externally, and this carrier wave is generated through this IC 8038. Then FM modulated signal means what will happen? Whenever the message amplitude is more or positive, you will get high frequency. When the amplitude of the message signal reduces, when it becomes negative, you get lower frequency components. So you get high frequency and you get lower frequency, and this will be repeated depending on your amplitude of the message. Depending on the amplitude of the message, the frequency of this carrier wave frequency will change. You may get higher frequency, lower frequency, and this will be depending on this amplitude, it will be changing with higher and lower. Okay, so what we have to do here is, from the CRO, please see here. Okay, see here we are getting higher frequency and then lower frequency. At some position it is moving, because some position it is coming as higher frequency, here higher frequency, again here it is lower frequency. So measure the F max and measure the F min. Okay, it is since it is every point of duration the amplitude is changing, so you will get high frequency, low frequency, and this will be changing. Okay, so measure the low frequency and measure the high frequency, wherein you will be measuring this F max and then F min. Okay, measure this F min and F max from the CRO, and you have to calculate delta F, that is frequency deviation. From the CR scope, whatever the F maximum frequency you have measured minus minimum frequency what has been measured, whole divided by 2, that gives you the frequency deviation. So from the frequency deviation, next thing is modulation index. Okay, modulation index is nothing but delta F by Fm. From the calculated delta F divided by the message frequency. In this message frequency is, we have given 4 kilohertz, that can be used, and calculate the modulation index. Then frequency sensitivity is this deviation divided by amplitude. So wherein deviation you would have already calculated divided by the amplitude of the message. Amplitude of the message here we have set as 4 volt peak to peak. So that can be used, and you can calculate frequency sensitivity. Last part is bandwidth. Bandwidth is nothing but 2 into delta f plus fm. Delta f you have calculated now, and fm is the frequency of the message, that is 4K. You can use that and find out this bandwidth. Okay, so this is about modulation. So the modulation has been done using IC 8038, and next part is we have to do demodulation. Okay, for the demodulation we'll be using this IC called LM565. Okay, demodulation is also now done. We're using IC LM565. This IC is phase lock loop IC. This is a PLL IC, phase locked loop. Okay, so actually in this PLL IC it will have mainly 3 blocks: a phase detector, voltage controlled oscillator, then a filter with the amplifier. Okay, there is a filter, a low pass filter with the amplifier. So 3 components are there, 3 blocks are there: phase detector, VCO and amplifier. Okay, wherein the thing is the input to this IC will be given through pin number 2 or pin number 3. Okay, so what we'll do here is, let us not use this pin number 3. We'll apply the modulated signal. The modulated signal will be applied to pin number 2. Okay, modulated signal will be applied to pin number 2. That is nothing but that modulated signal will be giving through pin number 2. We are giving that to the phase detector. Through pin number 2, that modulated signal will be giving to the phase detector. Okay, so phase detector will compare one reference signal with this modulated signal and appropriate voltage proportional frequency components it will be giving out. Okay, so from the proportional frequency components, this amplifier will give you a particular DC voltage. Okay, and that DC voltage is only nothing but the message signal. Okay, that DC voltage we are plotting, that is nothing but the message signal. Okay, so that message signal we can observe. I'll show you here. Okay, we can observe through pin number 7. Okay, through pin number 7, the DC voltage what is coming out, I'll show you here. This one, demodulated output. Okay, demodulated output is pin number 7 of this IC565. So we can observe that here. Okay, so I'll just show you that. So the first thing is, let us make the full connection. Now already using IC8038 modulated waveform is there. That modulated waveform you connect that to pin number 2 of this. Okay, from the 8038 whatever modulated waveform generated, that you connect here to pin number 2. Once this is done, and all this full circuit connection has been done, then we can observe the output from pin number 7. There is one more RC filter has been connected here. From pin number 7 it will go to this RC filter, and then here we can observe the demodulated output. Demodulated means we should get back the original message signal which we have transmitted with a frequency of 4 kilohertz. That should be here. We have to get the demodulated output. Okay, so we have done all the circuit connection. This is IC565. Okay, this is IC565. So to this IC, pin number 2 of this IC, this is the pin number 2. This pin number 2, we are giving this modulated waveform. Okay, the modulated waveform, the modulated waveform which is coming from this 8038. Okay, at pin number 2, 8038, it is modulated output. That modulated output we are connecting as input to this IC565. Okay, so and once you have given this whole circuit connection and this input, now at pin number 7, okay, from the pin number, this is pin number 7, you have connected this RC circuit. So at this junction, at this RC junction, we are checking the output. Okay, so that is connected here to this scope, to this CRO. So this is the message signal. This is the message signal. So the whatever the original message signal we have transmitted, that we are getting back, we are demodulated output. So we are able to realize this message which must be of the transmitted message signal frequency, that is 4 kilohertz. Okay, so in the end we have to also you have to measure this frequency of this message FM equal to, it should come near to the transmitted frequency, that is here it has been set as 4 kilohertz. Okay. So this is the whole experiment demo of FM modulator and demodulator. Okay, you can see this message signal setup. Okay. Yeah. Thank you.